So, welcome to the stage, huge panel. Experts in the future of manufacturing, I hope. The crowd gets slightly bigger every panel. That's a good sign. Maybe I'm not doing such a bad job after all. As I said to you guys just a moment ago, and the crowd has heard it as well, I encourage you to yell out and take advantage of the fact that there's a smaller crowd, and yell questions out, raise your hand, throw something at me, engage, and take advantage of this opportunity to speak to people that maybe we don't always have opportunity to speak to. So, I would really quickly, since we have quite a bit of time, a little bit at least, to take just 1 second. You get like your name and 2 lines about what you do, and that'll give everybody a little bit more insight into at least who you think you are. We might present it in how we think it is, but who are you?
Well, I start. My name is Tauno Otto. I work as a professor of manufacturing at Tallinn and lead the Smart Industry Center.
I am Ignacio Secades. I am an electronic engineer, and I am an expert in rising up startups that fall down.
I'm Bruno Siciliano. I am a professor of robotics at University of Naples, Federico II in Italy. And I'm also the director of the Interdepartmental Center for Advances in Robotic Surgery.
Hi, my name is Martin, and I'm an engineer by lifestyle, and I'm also the CEO of Factory.go. That's a startup connecting manufacturing companies.
Hi, my name is Kristo Vaher. I am working in University of Applied Sciences. I'm working as a project manager. My job was to build up a new laboratory about Industry 4.0. And also I'm a curriculum coordinator of electrical engineering. And from lifestyle side, I am mechanical engineer.
So, yeah, hello. My name is Aleksander Tõnnisson. I'm by education engineer, by lifestyle not anymore. But I'm co-founder of Build It Hardware Accelerator, a managing partner in our own seed fund.
Okay, so let it begin. I think one really good place to start is with a big open question, and that is about reality itself. So I'm curious, within the manufacturing world and kind of advanced technologies within that world, what is the current state, the state of current affairs, so to say? What's the state of the union? And what's the perception of what's going on now versus the reality of what's happening and what's coming? There's so many people, it's hard to figure out who starts, right? But I'm curious, what are the current innovations we start to see maybe in your specific industries?
Maybe one thing what is combining that today and tomorrow is virtual reality and augmented reality. That already today many laboratories have both sides. That we program and practice with real robots, but also we do the teaching and control over the internet with virtual digital twins.
In the field of robotics, I think we will see every year more collaboration between human and robots. From the software side, from the hardware side, I think we will see a lot of work in this field.
So the idea that maybe it's more about a collaborative effort between robots or automation?
Yeah, so not robot working alone or human working alone, so finding some kind of hybrid work.
And if I can elaborate, I think the big novelty is about the use of robotics and automation technology for small and medium enterprises. Of course, we have the big players, the big companies. Those have a kind of well-established tradition in automation and manufacturing. But nowadays, there are a number of small companies which they can develop automatized solution in a sort of plug-and-play fashion. So they can develop an application, and they can customize the application as intuitively as a teenager would use a smartphone. So that's the real thing. And this is lowering the barrier of some kind of companies using the conventional technology, because they can see the advantage of being able to develop a new application in manufacturing in 2 hours' time. So that's a big change.
and also the price of this system are really low compared to...
Exactly. So that's...
Yeah, the robots' prices are going down because the production of the robots is increasing, and you can have a cooperation robot less than, let's say, around 30,000 euros. It's the average 1 year salary. It's quite cheap already, and if you want to have a quite simple movement robot, you can have it for 1,000 euros already. That can make the very simple movement, picking and placing.
The user interface has dramatically reduced the overhead cost, so it's quite a lot more easier to implement those robots and to change the tasks on them, because like a few years back still you had to have like a huge line working a lot of quantities to make the use of robots necessary, but now you can have a small batch of order and have robots do it.
I think part of your question was perception versus the reality, was it?
Yeah.
Yeah, so maybe looking from our perspective, as we work a lot with young companies wanting to bring a product on the market, I mean, a product which you have to manufacture. So the whole our portfolio consists of companies which actually have something which you have to manufacture. That the perception is, as also maybe you guys said, that the entry barriers are much lower than they used to be. The reality is unfortunately not necessarily like that. So it is really true that the entry barriers to create something, internet-connected device, have tremendously been brought down thanks to Arduino in large, and then 3D printing and smartphone and blah, blah. But so it's really easy to create an internet-connected device. I just came back from a panel where we had I think he was 12-year-old, who has created a smoke and gas detector combined, which pushes the notification on a cloud. So a 12-year-old can build something like that. It doesn't mean it's a good product, but it's possible. So entry barriers in that regard has been lowered, but yet still most of hardware startups die just before they go into manufacturing, because this is still bloody difficult. And it's still as difficult as it was 20, 30, maybe even 40 years ago. So the term sleep on the factory floor is still very much true, because design for manufacturability is really, really difficult. And this is something which hasn't really changed a lot. Even thanks, I mean, you have tools which makes it a bit easier, but at least looking from our perspective, going into manufacturing is still super difficult, very expensive, and time-consuming.
Is it because of the gap in the communication between the startups and traditional manufacturing companies, or the availability of knowledge for design for manufacturing, or where do you see this problem?
It's both. The gap in communication mostly means that there's no communication very often. Yeah. So they include, let's say, a potential factory too late in the life cycle, and then very often it means also something which I didn't realize before we started this venture, was that a lot of the stuff which you can create as a prototype is not manufacturable. A lot of it is not manufacturable. So, and this is what happens a lot. So if you already have a prototype and you have some kind of traction from the market, and then it turns out you cannot even manufacture this, then you have a problem. And so that's one. So they include these people too late in the life cycle. But the reason for that is it's still fairly expensive. So to have that kind of know-how or people involved costs a lot of money. So that's also, I guess, one of the problems why they include them too late. And a lot of it is communication. I have to agree that just instead of picking up the phone, trying to solve your own problems and trying to reinvent the wheel, it's kind of a definition of an entrepreneur. You want to invent something new, even if it has been done 100 times before. You still try to do the same mistakes all over again. So that's also, by definition, already so.
Maybe it's interesting then, because you mentioned that one thing that's changed is the barrier to entry. What are the biggest, since we're going to go 10 years in the future, if we go 10 years back, what are the biggest shifts that we've seen in the past 10 years, if we include things like the barrier to entry and the price prices being driven down. What are the biggest shifts that have happened in the last 10 years in manufacturing?
I think the bigger issue is that 10 years ago, production were in very big quantities. So they produce one model of one system, one car or one everything, and they produce a lot during a lot of time. And in the future, we will work with smaller stocks, personalizes, and more flexible production.
And also, like 10 years ago, the role played by the so-called system integrators was crucial to the success of the implementation. So, I mean, there were like specialized companies and experts that without which it was not possible to automatize and to do some kind of automated manufacturing. Nowadays, just as you say, thanks to the friendly interfaces, I mean, just the stakeholders, they can develop their application and they can reach a good level of automation on a kind of self-made, job. And this is a big change and this is also what has contributed to lowering the barriers. So, I mean, this is happening, and you have a variety of applications which even before they were not even thought as a possibility to be automated. So, like for instance, we were discussing one of the sessions about food, and now people have realized that not only in the classical packaging for the food industry, but also for preparation of, like in a kitchen, you can automatize and you can use some kind of technology without being an expert, because this is becoming more and more user-friendly, and any kind of person can develop a solution.
Yeah, as mentioned before, the quantities of the same products have come down. This is partly due to the fact that the prices of manufacturing have kind of leveled in different parts of the world. Like when 20 years ago, everything was moved to China, now it's moving back. So it comes closer to the end user, which creates also more customizability within products.
One thing more what is changing to look history and what is coming in the future is that connecting different producers' machines together is much easier, because the same interface thing is because the customers usually don't like to buy all the factory in one time and from one company, but they want to have one machine from one producer, one next year another machine from another producer, and how you connect those machines. This is something that was very hard in the past, but in the future it's going easier and easier to connect different producers' machines.
Yeah.
This is making life easier for the small companies also.
So actually, we discussed briefly on topics that you'd like to cover, and you specifically mentioned connectivity and collaboration and this sort of thing. So is the vision for manufacturing in the future to be more of a system and less of a singular unit, more connected?
I would say so, yeah. When the Industry 4.0 first came out, the main concept of it was automation on the shop floor, but like many industry leaders have said that the vision for 2030 is more on the side of connectivity, that every manufacturing company can focus on one specific thing that they do very well, and through mutual collaboration we can give out better products with lower prices and better quality. Yeah.
I remember one presentation where was I don't remember what the exact term was, but I remember something like wet dream of Industry 4.0, is that, and then this is what all the factories are working towards, is that by the time where the engineer draws a window on a future building, the factory already knows that this is the window that they need to produce in half a year. So that's kind of, I guess, the idea where the Industry 4.0 is moving towards. However, it's much more slower than maybe anticipated in the beginning, because that means a lot of collaboration. And collaboration happens between humans, after all, and not between the machines. That's something that you cannot solve with software so easily. And that's still an issue. But there is an interesting use case from Netherlands. They opened the factory, I think a month ago, something like that, either in October, maybe beginning of November, where I think it was 13 startups and bigger manufacturers. They put their backs together, and they have built a collaborative factory. So a factory which can produce all 13 products. It is co-owned by all 13 startups, plus then a few bigger players. And it's a shared space where you can, all these 13 startups can produce their products. So that's pretty cool. It's almost fully automated. It's very easy, modular. So you can build a product line in, I think they said, in 3 weeks. You can build a complete new product line. And by the way, our neighbor country, Latvia, is planning to, so there's going to be a factory very soon near Riga airport, which is specialized on small quantities. So this is definitely a trend. And I think one of the reasons is also that, but if you want to test the product in a real market environment, you don't want to manufacture 50,000. You would like to start with 500, and currently it's very difficult to get a small batch. It's easy up to 100. It's easy starting from 5,000, and anything which is between 100 and 5,000, it's very difficult to find somebody who wants to take that order. So, even in our neighboring country, there will be a prototyping factory which can assemble any product, or the idea is that you can go walk in with an idea and come out in 2 weeks with a product.
I guess then this ability to print in small batches really fosters innovation, or at least testing of new products, and allows for kids with smoke detectors that can detect gas leaks to make their thing maybe at in a larger quantity instead of just the one tinkering toy. Is there other benefits to being able to print in these tiny batches and to be able to create stuff in smaller units? I imagine there's even economic impact benefits where you don't have to constantly be outsourcing to other countries, maybe.
I think what you are looking is to be as much as you can near to the customer, to the final customer. So each customer have a different need, and you need to solve this need. So if they want to buy a new car, each want a different color, a different application, and your line, your production line, needs to be ready to be as flexible as possible.
But it's very European way. But I think in Japan and in US, it's not so big question.
Yeah, but I think it's the trend. I mean, 5 years ago, you just can choose between two different models. Now you can select different extras, and if you want to make a different product or personalize your product, you need someone to produce them. And the factories need to be more flexible, and the work needs to be more collaborative between all the components, robots, human, and everybody must work together.
I feel like you have a disagreement with this.
Well, I have just visited US, and I was quite surprised at a big conference, mechanical engineering, and there was no topic about Industry 4.0. And when it was brought out, then they said, okay, very interesting idea. Well, let's do it next year. But I think that digitalization, what is very hot topic in Estonia, it's not hot in all over the world, maybe.
So, briefly was mentioned, Japanese neighbors and this sort of thing. One topic that was interesting to me is when you're researching manufacturing and automation, Asia is kind of a huge buzzword. Is this is where all the hype is and where all the automation is. Is it true that that Asia is light years ahead of the rest of the world in automating manufacturing and introducing robots on every factory line? And is that okay? Should Europe push harder to be more automated?
Well, I guess it's kind of obvious. I mean, so there's no question about whether automation comes or not. It will come. So there's absolutely no question about that. And it really depends in what factory you visit in China. So I've been to Foxconn, which is the world's largest manufacturer, and obviously they are state of the art. I mean, by far. And also in Taiwan and North Korea and South Korea, sorry. So there's no question about that, which doesn't mean that we couldn't be moving towards the same goal, trying to automate as much as possible here in Europe. And this is indeed happening. But again, the perception and the reality is, at least in the Estonian case, and Martin can, for example, confirm that, I guess, is that we talk a lot about Industry 4.0, but most of our companies are maybe Industry 2.0. Yep. So you cannot skip 3.0 in between. So we talk about it a lot. The reality, unfortunately, is that we still need to do 3.0 in between, and then we can talk about 4.0. So I think US has probably much more realistic in a sense that you cannot talk about something which cannot exist because you have skipped a step in between. And same with the US, so we have companies in our portfolio who are trying to solve the problem. And you would be amazed how many manufacturing companies in Estonia alone do not know how many pieces they produce in a day. Still, they just produce. I have no clue how many. You would be amazed. And so, and talking with that company about ERPs or optimizing supply chains or Industry 4.0, it doesn't make any sense because it's not the language which they understand or they don't even want to speak. So maybe that's just an interesting fact. So I would also like to speak sometimes on so not how the manufacturing is different in 12 years from now, but actually what can we do today to help these companies to come to the level where we could talk about how to implement what is already available today, not in 10 years.
Actually, that was my next question, is why is that the case? What's hindering?
Martin, maybe, I mean, you talk to the guys every day, so you must know.
Yeah, well, probably one of the main reasons is fear and not having enough knowledge about it. So it's very natural not to want something when you don't know anything about it. So when somebody comes at you with a really big vision how everything's going to be better, how everything is going to be automated, the first thing like an average company hears is, okay, we're going to lose our jobs. So how to communicate to the companies that, no, you're not going to lose your jobs, you're going to be more efficient, more productive, and people that are working in your company who have very high skills in different areas of manufacturing, they can actually work on things that really add value, not fill in papers and not phone somebody about where is this specific casket laying around.
Huh.
If I can add something,
please do.
I think a big change and also, is contributing to improving the acceptability of automation by the workers is the working conditions. Because a few months ago, I was in a distribution center of DM, Drogerie Market, which is a big retail company in Germany, as well as in other countries in the former Eastern Europe, in Austria and Switzerland. And we have a research project about taking robotics and logistics for refilling the shelves of retail stores. And we had an interesting meeting with the trade unions of the distribution center, and we explained to them that also our mission is to improve the working conditions. And this is the case, for instance, of the ergonomics for the workers. And this happens because, for instance, of wearable robots, of exoskeletons, and also since we were talking about 10 years ago, the big difference, I visit one plant which is close to my town in Napoli, and this is a big FCA, Fiat Chrysler Automation. They got an award a few years ago for the greenest plant in Europe, because I was really impressed. This is like an automobile plant, and to me it looked like almost like a pharmaceutical plant, because everything was white, no noise, and more importantly, the sequence of the parts along the chains, the spatial-temporal sequence was commanded by the technicians. So it's not that you have to do a certain manual operation at a certain point, with a certain time. So this is a big change. So automation means not only to replace the humans, but also to put the humans in better conditions to do some kind of manual work.
Awesome. I want to take the opportunity to take any questions that might be from the audience before the end. Yeah.
A question maybe more towards infrastructure, but would you say what will be the key point in the future is collaboration, smaller factories, connections and so on. But do you really see the infrastructure being built for that now? Because I'm based in Berlin, and one of the politicians just said, oh, we don't need 5G everywhere, 4G is enough for everything to do. And isn't that like the biggest hurdle, not having to buy in of the countries and European Union, whatever it is, to provide it? And also infrastructure and logistics.
So the question is, if we want this collaborative future and to see Industry 4.0 really happen and to push innovation, is government buy-in or maybe the powers that be a hindrance to making that happen?
I think in Estonia it's already a reality that you can see that the Starship robots are already moving around, and now today is news that the clever robots are coming also to the roads. So it's pretty evident, and I can see that the student works, theses coming from industry are more and more related to artificial intelligence and machine learning. So it's coming up silently.
But I think even if the governments say right now that we don't need it, when business world says that we need it, it's going to come eventually. So it just maybe needs more incentive and more investments from the private sector. But if the governments don't help, then we need to do it ourselves.
Maybe I have a question to the panel, if that's okay.
Have at it.
And one of the things which I've been thinking about, and since I haven't come up with an answer, maybe you can help me, is that we visited it's not now directly connected to the manufacturing, but very much connected to the future of manufacturing, is that when we visited a e-commerce expo in Berlin, there are now companies which have a software platform available which can create a description of any product in any language. So mainly now your competitive advantage if you're selling your products on Amazon, for example, is that your description is better than your competitors, your pictures are better than your competitors, but now there's a software available which can automate that all. And now the question about the manufacturing is that, so if we automate all the processes, and even a 12-year-old can launch a product on the market without knowing anything about the manufacturing because it's all connected, and design for manufacturability is done by AI, for example. So where is the value created in the future? So that's something which I think is an actual question we should be asking, is that if we automate all of that, so where does the competitive advantages of the future come from? Where is the value created? So if there's no value created on the factory because it's fully automated, so where is the value when resellers is fully automated? So that's something which I've been kind of wondering and looking something 10 to 15 years ahead, but I haven't been able to figure it out.
Well, it sure is a long way till we reach that, but then the value comes from this, the imagination of this 12-year-old. That's where the value comes.
Maybe.
Then we don't need engineers anymore, just soft lectures
Probably.
to get the imagination at a good level.
I also foresee in 10 years from now, there will be some mansions in a plant for manufacturing which do not yet exist. In the sense that, with the current technology, we see some roles, we see some jobs, some mansions, but, with the development of technology, I think there will be some professional figures, some mansions that, are yet to be identified, characterized. And to this regard, I think, just like the same kids that nowadays they play with Arduino controller in the schools, with the kids, will be in a kind of privileged position to take over this kind of new jobs that will be created in manufacturing. With the soft skills combined also with the capability of developing an application with parts and motors and sensors in a very fast time. Yeah.
We have time for one more question, if there is one. Or from the panel, if there's another question.
I mean, education is always an interesting topic. Many of you deal with daily. How do we get more young people interested in manufacturing?
I have a good example from kindergarten. My daughter is 4 years old, and there was Father's Day, and there was a special program, and my daughter teach me how to program a robot. There's Osbot. You draw a line in different colors, and it moves on the line. So I think it starts very early. So I think our future is secured if it goes like this.
And also, I think what is changing is the perception by the people, because manufacturing was regarded always as a sort of dull and dirty, something which people didn't want to deal with. But nowadays, I think, just with techniques like additive manufacturing, rapid prototyping, the image of perception among the common people that it's really cool. So this is also a sort of, in my opinion, a kind of resurrection of the old concept of manufacturing as one-to-one with the factories. You can do artistic work in manufacturing, and this is perceived by the youngsters, by the new generation, and this is also very important because, I mean, the game will not be confined only to the classical companies, like the usual players, but there will be new players into the game, which they will still do manufacturing, but with a complete different perspective.
Awesome. And on that note, thank you, panelists, and thank you, audience.
Thank you.